which kind of takes us to the next area. So again, data networks, and now we're building on operations and how to effectively manage those. What does it mean now in terms of your data and your data assets, and how do we go from just data to trusted data? And what is trusted data? Well, trusted data, or the concept of trusted data, has been around a long time. I mean, it's been around when I first entered the industry, which is an awful long time ago. So I'm not going to tell you how long that was, but this concept of embedding security within the data itself, our secure or self-aware data objects, has actually been an area of research of mine for quite some time. But what does it mean to have trusted data? That it's sound and it's reliable, it's accurate, and it's secure. So all these things that that build on the integrity of the data itself, that it's valid and it's attested. At the core is this concept, again, as I mentioned, secure data objects, and really there are a couple key aspects of secure data objects, and one is definitely becoming very prevalent because it gives you a lot of flexibility in how you use and access data. So at its core, it's the data itself. And then we strongly believe, from a security perspective, you're going to see security attributes embedded in data, in individual data objects themselves, in terms of who owns them, what they can do with a particular data object, et cetera. The other aspects are the concept, and these kind of go together. Metadata and attributes. What's the basic attributes of that piece of data, and as it translates to metadata. So in the concept of attributes and metadata, what it allows you to do is represent a given data object in different ways. We see this a lot in the health space. For instance, how inside a given electronic health record, there's different ways to represent something simple as weight. And I'm not talking about pounds versus kilogram. Weight, let's take a child. Was the child fully clothed with their shoes on, or, did they just have a hospital gown? And why is that important? Because, again, medication dosage for certain types of medications are based on weight, and it become very critical. So this aspect of really putting data in context through metadata and attributes is very, very, very important. You're going to see that become mainstream in pretty much any type of data management solution. And it's definitely necessary when you're connecting different organizations and different processes, because there's no way we're ever going to get to a common data dictionary or data architecture. Lots of people pushing that in standards. Personally, I think it's unattainable because the rate of data and data production is just growing too fast to say, hey, we're going to just standardize everything, let alone going forward, let alone going back and kind of revisiting all the data that's in, all this rich data that's in a lot of these repositories. Okay, trusted relationships. That last layer on that secure data objects was edge relationships. It's time for graph models and graph data structures to come to the forefront. We spent a lot of time forcing data into structured definitions like SQL structures, or for analytics, stars and cubes. Really, and there's been industry segments, kind of specialized segments, that have understood the power of graph technologies. We all have a social graph, and everybody's heard of your social graph, and this notion of 6 degrees of separation. Well, you're going to see that emerge in terms of how you build data relationships and data constructs. And why is that important? Because once you have these edge relationships, and once you understand how they relate to one another and what capacity, you're able then to take these kinds of structures and present them in a way that's consumable by an application or a business process. So it's time, and you're going to see these notions of graph models, particularly in data sets and around personal data, really emerge as kind of a core construct. And the last aspect of graph models, they're multi-dimensional. Really, what we're talking about is not just how a piece of data relates to each other. We're talking about including kind of longitudinal, temporal based kind of data sets, as well as geography or positional, and all kinds of other really cool attributes around the data. Because the last thing, in a lot of industries, there is a time value to data, right? something's really required to make a decision in real time, the value of that piece of information can be reduced over time. So what we're really having to do here in these constructs is build in these kind of attributes, again, within the data itself. Okay, verified credentials. Verified credentials is a a World Wide Web Consortium standard, a W3C standard. There's still some variations in the core standards, but they're really beginning to solidify, and they're beginning to solidify around distributed identities. We work with an organization called GLIFE, which is a legal entity identifier for businesses. Mostly outside of the US, but we're starting to see it get adopted within the US. And what is a verified credential? Think of a digital certificate, in a standard form, a digital certificate, to represent a piece of data and attributes of that data, and disconnect it from the data sets itself. So, based on the attributes and using cryptography to guarantee the integrity of the digital certificate, that is an accurate representation of a piece of data, and it has the mechanisms to validate if that data is still accurate and current. So one tactical example of how this technology is being used, it's emerging as kind of the preferred technology for things like health credentials in terms of individuals' educational credentials, as well as health passports. Did you get vaccinated or not? In a way that you can share that data without compromising your privacy. So again, it's a way to disconnect trusted and attested data from kind of trust anchor or trusted sources.